All right, ladies and gentlemen, we are live here in the studio with a very, very, very special guest who basically started to take down the internet by storm with two MacBooks are all you need. With AC Crypto of XO Labs, and AC Crypto goes by Alex Cheema, is one half of XO Labs, and the other half is Mo Bayomi. And on the phone, actually, we have Ronald Manak joining us. Hey, Ronald, how's it going? Cool. So yes, this is a live stream, ladies and gentlemen, and what we're doing now is that we're actually inviting you to ask questions because we have Mo in studio, and Mo was able to accomplish this amazing feat where he's able to get one of the largest language models that has been released, that is open source to date and available for the entire public. The only problem is that it can't really run on one computer without completely breaking down and crashing everything. So what Mo has actually figured out is a way, Mo and Alex and XO Labs have figured out a way to run this whole thing and split it between multiple computers. And this is the really interesting open source invention from XO Labs. And so we're really delighted to have them here on the show and the live stream. So for those who are just tuning in, welcome. We're currently live on Twitter. We're currently live on X. We're currently live on Twitch. And so that means that you can log in and just start asking some questions. And so definitely start bringing the questions in. We got a couple cameras here. We got not only this guy, but we also have the really clean VIP camera look, of course, for the look. If you kind of look up here, Alex, you can look up to the camera and wave it at everyone. We got the, got the vibes. Yes. So definitely going to be flowing here, and definitely appreciate the people going in. So if you're seeing this right now, hit the retweet button. This is about to be a really crazy show. So we're, happy to have you here, Alex. How's everything?
Good, great to be here.
That's excellent.
Yeah, I'm excited to go deep on what we've been building, and the tweets that we've put out recently have got a lot of attention.
Yes.
But it's quite surface level, so this is an opportunity for people to ask questions and go a bit deeper on what exactly we're doing, how it works.
Yeah, I think it's really important, especially in this open source landscape, to talk about what was going on. And so just a little bit of backstory. What has happened is that earlier this week, just this week, Meta has released the 405 billion parameter model. And this is the model that we've all been waiting for this entire year. And it's so large that it's literally 800 megabytes plus. Or, sorry, 800 gigabytes. Yeah,
almost a terabyte.
Yeah, almost a terabyte. And literally...
the base, the FP16 one, the sort of the normal one, pre-quantization, is like around 800 gigabytes.
That's amazing.
That's a hard drive full of weights.
Right here, we have the weights literally right here, and this was what happened is that you were trying to get this set up, and you're having so many issues downloading them from Meta's website and actual Hugging Face that you put a call out and you said, hey, we need to figure out a way to get the weights onto my machine, because then I need to do some magic so that we can do this thing. And so I saw that, I was like, aha, let me see if I could use up my bandwidth. And I actually downloaded the entire weights, and I got notices from Comcast. People were screaming at me saying, hey, you've used up all your bandwidth. I was like, I just started the download. I don't understand what's going on. And this
is something I haven't run into before, where you need to download so much just to run a model that it takes a whole day. It would have taken me, I think, 1 to 2 days, I calculated, based on my internet speed. Mm-hmm. So it was great that you just happened to be literally 5 minutes away, so you could over the counter physically come and give me the weights.
That's what we do around here,
deliveries. So if anyone wants a startup idea, maybe you could create a physical weight company that comes and gives you a hard drive full of all the latest models.
Yeah, that'll be super fresh, and just connect them right into your data centers and stuff. And so what happens basically, and why this is really, really important for everyone who's just tuning in. So for those who are just tuning in, we have Alex Cheema, who we're talking here from XO Labs, and he did this demonstration where 2 laptops are basically sharing inference for one of the largest models they've released to date. And this open source model is on par / beating the current closed source models from OpenAI. And so what that means is that you as a consumer can possibly, this is just like the first step of many types of things where you can run something on your local infrastructure and not have to depend on these larger companies who are like maybe doing different things with their models and maybe doing censorship or allowing different things to happen, and then you have full control of it and you can do whatever you want. So yeah, tell us a little bit of background here of like when you started this project and kind of what got you into this whole thing here.
Yeah, I was just trying to pull up there's a really good picture that someone made recently of sort of the timeline of the last 2 years of all the models that have been released, both closed and open, and sort of just how the performance has got better over time. And it's improved dramatically in the last few years. I mean, I remember, I think it was maybe 3 years ago, using GPT-2 very early on. I was working on a mobile game.
Please fix Alex mic. We can't hear him. Bring up the volume.
Oh.
Are you guys able to hear Alex at all right now? Let's see.
Test.
Test,
cool
test,
that you
test.
can see
The comments?
the comments.
I think his mic is off. Let's see if I can get this going here. Because, yeah, the output should... Yeah, let's go ahead and just double check this. I think it's really important to get this audio set up correctly. Let's see. So can y'all, okay, you guys can hear him? Give the thumbs up.
Test.
Test,
Can you
test,
hear me?
test. He sounds far away. Oh, I think we can hear him, but it's low. Oh, I see. So you may have to just put the mic. Let me get this water. We had a little incident earlier where the water was...
Oh yeah, we don't want that again.
Okay.
That delayed the whole thing. We spilled coffee all over Ray's desk.
So maybe move it more in front of you, like directly. Yeah. So how's that?
Test. Is that better?
Yeah, is that better, everyone? Yeah, this. Okay. It does sound like the external mic is recording. Okay.
Okay.
Cool.
Test.
Yeah, he sounds... Okay, that was earlier.
It sounds far away.
Yeah, maybe because I was talking here. Test.
Test.
I think we're good, right? Yo, give another thumbs up if you can hear it. Then I think we're going to be good here. So
Is it still far away?
sounds like it's coming from the wrong mic. Let's see. You should be able to hear.
Hello? Test. Sound is coming from wrong mic.
I wonder if I should fix the routing. Let's see.
Yeah, it might be coming. Yeah, it's probably coming from the other mic.
Cool. How about that? I think it should have worked already. Do another sound check here. 1 2 1 2.
Sound check. Test.
Yeah, I see the audio coming in. Oh, you know what? I think I know what's going on. Haha, my bad. I think I fixed it now. So I totally messed this up. Ask the AI. Yeah, so the sound should be working now. I had the audio, I had the audio routed the wrong way, so still worked. The audio was actually coming through, I think, from my MacBook, which is why you may not have heard the whole thing. So check 1 2. You should probably hear it a lot better now. Let's see.
Test 1 2.
Yeah,
Is that better?
I think it should be better now, because yeah. Cool.
Okay, we have 102 people in the live stream. That's quite a lot.
So I think, yeah, we should have the audio should be coming correctly now from, oh, it's coming from the MacBook microphone. Oh gosh, Jesus. Okay, so it keeps switching over, and so I need to go to Rode Unify Chat. No, Rode Unify Stream, I think. There we go. Now we should have the audio. It should be fixed now.
Is that better, guys?
Yeah, that should be way better. Thank you so much for giving us a heads up, because that would have sucked if the entire thing went through and you couldn't hear anything. I thought Apple was supposed to
Let us know if this is good now.
Yes. Yeah, I think this should be a lot better now. Go ahead.
Test 1 2 3.
Nailed it. Perfect. All right, let's go. All right, let's just restart the show. Let's go. Yes, the vibes. Okay, so you may not even have heard the intro music. Let's just run this back. So it's all good.
We have
Cool.
a lot more people in the stream now. So
Yeah. Yo,
So
thank
good.
you. All right. Thank you, everyone else, for helping us warm up the stream. Get the audio fixed. That's definitely huge, huge, huge. Let's go. That's what I'm talking about. All right. For those who are just tuning in right now, we have Alex Cheema. Alex Cheema of XO Labs. And this is a really pivotal moment because what we've been able to achieve, what actually the few is Alex and Mo and everyone who's been contributing to XO Labs has made an incredible accomplishment over the past week on the internet. And so for those who aren't familiar, this is the 2 MacBooks is all you need guy. But beyond that, you basically have been able to unlock open source software to be distributed at home in any doomsday scenario in any way possible. And I'm just really delighted to have you officially on the show. Microphone's working. One check, 1 2. We got you live. What's up, y'all? Ryan Carson, thank you for tuning in. And so this is a live show, ladies and gentlemen. And so what we're doing is encouraging everyone to ask any questions because what's happened is that with this type of thing, there have been lots of response on Twitter about your whole XO Labs project. How are you doing Inference and all these types of things? So this could be a very technical video podcast, and appreciate everyone kind of tuning in as we've adjusted the audio. It's all working now. And rumor also has is that we have a demo ready back here that we should be able to run on the devices. And a little bit of apologies for the delayed start. We actually had some coffee spill on one of the machines, but we have
my
bounced
bad.
back. So now we got
That's why
everything
we were
all
delayed.
sorted out. I'm so happy that this is going on. So Alex, thank you for joining us on the show today.
Yeah, thanks for having me, Ray. Excited to go deep on what we've been doing at XO. And yeah, we had a few tweets that went kind of viral recently. One of them was the 2 MacBooks is all you need tweet. But yeah, like it was a lot of people were asking a lot of questions in the comments. And I want to take the opportunity to just take questions from people and sort of go deep on, more of the technical side and, what we're doing, what the vision is here, and why we think this kind of technology is important for the world.
Yeah, I think it's just really amazing. And for those who don't know, that basically we now have a GPT 4-level device, the 4-level model that's open source with the weights and everything, and that can run actually on your devices. And so if you try to run it on one computer right now, it's so large that the current computers today aren't really able to run that at this present time. And so what Alex has done is made some software with the open source community, XO Labs, to distribute the inference. And so tell us what inference is, because people hear these terms, and then kind of what that has to do with, how this breakthrough has kind of occurred and how you kind of got started with this project.
Yeah, so the simple way to think about these big models is they're just a giant black box. And that black box is basically just a program that runs on your computer and consumes a bunch of memory. So these black boxes, just inherently the way they work is they require a lot of memory and a lot of compute power to sort of get results out of the model. So the model is, you give it an input, which might be a prompt, and the output is some text. It could be video, it could be an image. The models that to date have been got the most attention are large language models, and these essentially take in text and spit out text. And through that, ChatGPT is probably the most well-known example where you have a chatbot interface that allows you to chat with this model. So the input there is questions and prompts that you give to it, and the output is a response from a chatbot. And yeah, up to date, the best models that are available have been closed source models. So ChatGPT was the best up until recently, and now Claude Sonnet has, overthrown GPT-4, ChatGPT, and now it looks like open source models have finally caught up. So I mentioned earlier there is a really nice just visualization of this that someone put out. I don't know if anyone can like put it in the comments or something, but it basically showed over time, over the last few years, how these models have progressed, and they've got bigger. So that's just a common trend, and they've also got better. So the kind of general trend here is that you need larger models to get better results out. So there's, these scaling laws, which basically say that, the more compute you put into the models, the better they get. And the larger they are, the better they get. And so what you've ended up with is just, these models getting huge. And the most recent one that came out, open source model, that is competitive with the closed source models is this Llama 3.1 405 billion parameter model, which basically that means there's 405 billion individual numbers that the model is using to compute inferences. And that means you need a hell of a lot of memory on your computer to store this. So generally each one of these numbers is 16 bits, so 2 bytes. Which means, you would need 405 billion times 2 bytes, which is around 800 gigabytes of memory to fit this model. And the reason you want to put it in memory is because, when you run this inference, you're computing on these parameters. And if you had them on disk, then you would need to load them into, memory so that either the CPU or the GPU can compute on those parameters, which is very slow. Maybe you would get something like a gigabyte per second out of your disk, which would mean that would take 800 seconds to load the full 800 gigabytes from the disk.
Wow.
So you want to keep that hot in memory so that you don't need to go through the disk. And that's where sort of the main bottleneck is right now, because the models are so big. You want to fit them into memory, but GPUs, just consumer GPUs at least, and even enterprise GPUs just don't have enough memory to fit that all in one go.
Wow.
So a H100, for example, which up until recently was, the de facto enterprise GPU, has 80 gigabytes of GPU memory. So even in that case, you would need 10 of them to fit the whole model. Like MacBooks
That's
have
massive.
Actually a little bit more than that.
Yeah.
Huh.
So
It's even like the what is it, the NVIDIA 4090 has up to 24 gigs, right?
yeah, so that's like
So,
a typical
like
gamer GPU, and so a
yeah,
lot of people
yeah.
have that lying around, but it's just compared to, it's like 5% of what you would need to run Llama 405B.
Wow. That's incredible.
Yeah, that's crazy.
And so
So that means that if you're Windows, like an H100 or an A100, you cannot get as a small company or an individual. So if you don't have a Mac, you are basically limited to the 4090s, which again have like only a small amount of memory, right?
Correct. Yeah. So as a consumer,
Yeah,
that would be
yeah.
kind of on the higher end of what you might have lying around, and even then, you might have one or two if you're really, really into gaming. Then you might have that.
that's right.
So that's sort of where, I think Apple Silicon is really interesting, because, Apple have been quietly, in Apple style, sort of just working on unified memory recently, which I think basically what it is instead of having a separate area for the CPU memory and the GPU memory, there's just one single unified memory. Like Apple Silicon is just, there's a number of really nice things about it. One is it's ARM based, which is way more energy efficient than sort of other architectures. And if you look at, for example, a H100, it consumes 700 watts of power compared to, one of these MacBooks. So let's put this into numbers. So H100, it's 80 gigabytes of GPU memory. It's about one petaflop, so 1,000 teraflops of FP16 performance, which means it can compute, 1 1,000 trillion operations every second. And it consumes 700 watts. So if you look at sort of the ratio of, you can look at different ratios. I think it's one of the things that's really interesting to look at is just like, how the flops, the energy use, and the memory of all these different hardwares compare, and the ratios between all these things. So one metric that I think is really interesting is the ratio of memory to power. So in the case of the H100, or looking at the other way around, the ratio of power to memory, it would be 700 watts for 80 gigabytes of memory.
Wow.
So that's roughly a ratio of 10. So 10 watts per gigabyte of memory.
Jesus.
And then if you look at something like this MacBook Pro that I have behind me, this has 128 gigabytes of memory, but it only consumes about 40 watts. So the ratio there is more like 0.3
That's insane.
watts per gigabyte of memory, which means it's more than an order of magnitude more energy efficient per unit of memory than a H100 is, which is very interesting when you start to look at these very large models where you just need, all the parameters to sit in memory at once. And I think the thing that's really underestimated about this, like Apple Silicon, is the fact that it's unified memory. So it's not just that, when you customize your MacBook and you max out the memory, it's not like you're getting a bunch of CPU memory. You're getting both CPU memory and GPU memory.
That's right.
Which enables us to do stuff like we're doing with Exo, which is just running these huge models directly on these MacBooks.
That's amazing. Yeah, Miguel, thank you for the comments. Apple is cooking. It's actually cooking. Tim is cooking, Apple's cooking. The whole, shout outs to Apple. And so what does this mean for everyone? And what does this mean for everyone going forward in the future? So what's happening right now is that some of these models that are released with the current computers today, there's like all these limitations, right? And even the current GPUs that you have as a gamer are so limited. And then for the Apple stuff, from a consumer standpoint, just by default, right off the shelf, you're like, hey, we can do this stuff. And, it's not like it's maybe premeditated or anything. They just maybe kind of fell into that by accident. And then there's been people like, so tell me a little bit about how this stack works, because when you go as a consumer, you're going into ChatGPT, you go and type in some information and it goes to a server and that goes into some large company. And then they return back a response, back down from the internet. And so ChatGPT and OpenAI and those people have to have these servers with these large infrastructure sitting 24/7 consuming all this energy just to give you your responses hey, what's the recipe for making a cake? And, it's using all this machine power to deliver that. And it's, to be honest, it sounds like it's fairly power inefficient when compared to an Apple computer. And so the step that we're kind of going down now is here we are a year later after ChatGPT has been released with an open model that you can run using your Mac. There's a lot of different pieces of the stack. So let's kind of go into the stack now in terms of what does it typically take a PC to run at a very high level? And then what do you need for a Mac to run a model, So.
Yeah. So the current paradigm for AI is cloud-based. So you have these few companies that create giant data centers with thousands of GPUs that when you do a request to something like ChatGPT, it gets routed to one of these giant enterprise GPU clusters. And what they do is there's a number of advantages to doing that. So one thing is that you can sort of optimize your data center specifically for inference, and you can sort of build cooling solutions that get the best out of the hardware. Another benefit is that you can batch together requests. So let's say, for example, with ChatGPT, there's millions of active users. If 100 requests come in within 100 milliseconds, then you can batch all of those requests together and compute them all at the same time. And because GPUs are well suited to anything that's highly parallelizable. You can parallelize multiple requests on a single GPU at the same time, which gets the most out of the hardware. And I mentioned before, there's these different ratios between memory and flops and power. And I mean, one ratio that's very high for the H100 is that its ratio of flops to memory is very high. So it has, 1 petaflops of compute and 80 gigabytes of memory.
Wow.
Which 1,000 teraflops, so that's about 10 teraflops per gigabyte of memory. You look at a MacBook and it's 40 teraflops for 100 gigabytes. Let's say that's 0.4. So the H100 is really, in a way, it's like over provisioned for flops. So what you want to do is as much as possible batch together multiple requests so you can saturate the GPU in terms of how many operations it's running.
I see. Interesting.
So that's cloud is still very useful, and obviously this matters a lot when you're doing something like training, where with training you basically want to get as high utilization on those flops as possible.
Yeah.
And you can batch together a lot of requests really easily because typically when you train a model, what you're doing is you're giving it a load of samples, which might be something like text from the internet. So Llama, the recent Llama model was just trained on lots of public data from the internet, which might be stuff like Wikipedia, Reddit posts, etc.
I see.
And the way it works is it basically feeds in a bunch of text and then asks the model to predict the next word from that text, and then gives it a score based on if it got it right.
I see.
And what you can do is, because you have a load of text, you can basically parallelize all of these samples.
Yeah.
And so for training, you would batch together a lot of requests and send them all to the GPU at the same time so that you can saturate the compute.
We have a question here from the audience, which is kind of nice. So for those who have questions, please definitely send them through, and we're going to be looking at them here. So can inference be cheaper on a CPU versus GPU, or there's a new set of problems that are going to that route?
I think it depends on the use case. If you're running something at home, you might actually get away with using the CPU for a lot of stuff because, basically what I was just saying was with data centers, one of the benefits is that you can batch together a lot of requests. But if you just have your own personal AI cluster that you're using, then typically you don't really have an opportunity to batch requests together because the usage is very spiky. So you'll get you'll send your chatbot a message and then it will compute a bunch of stuff and then give you a response, rather than the economies of scale that something like ChatGPT can get, where it batches together 100 requests at a time and sends them all. So in that sense, you don't need a crazy amount of compute.
Yeah.
But you will experience high latency I because the CPU is just inherently slower at doing the kind of operations that you need to run a large language model. I think it's interesting to explore, and obviously you can scale up CPU a lot by just having a lot of cores as well, right? So or you can have multiple CPUs.
Yeah, because I understand in China they're trying to they don't have access to the GPUs, so they're coming up with clever solutions and training models and trying to come up with these different efficiencies. And sometimes out of those types of limitations, the new things can be born that we don't know of. And stuff.
Yeah, I think for at least for these big GPU clusters that I was talking about, that's going to stay as GPU. If you can use a GPU, it's just the more economical thing. But in terms of commoditizing running these larger models and democratizing that so that the barrier of entry is as low as possible, then potentially you could start seeing a move towards CPUs that are more suited for inference. And you're starting to also see the memory bandwidth getting a lot better with newer architectures for the memory bus.
I see.
So that you can just move more data around more quickly.
And we have a question from Miguel. Is it possible to use EXO with systems only CPUs?
Technically, it should be possible because we support TinyGrad, and TinyGrad has an option to use the CPU. The device is called Clang in TinyGrad. You might need to set that up manually because it will basically default to whatever it should default to whatever the best device available is. So if you don't have a GPU, it should already default to CPU. In which case you can run on CPU. I've done it before and it is slow. So I think this is always going to be the problem is you can do this, but it's just going to be very slow. But that's just, it's not, if you just look at it from first principles, like I was saying, these workloads are very spiky. There's no reason why you wouldn't be able to run more stuff on the CPU, especially if you, for example, pool together multiple devices. The main bottleneck right now is just in terms of the architecture of EXO. So EXO, in a nutshell, what it does is it takes this giant model, which, like we were saying before, it could be 800 gigabytes, and it splits it up into partitions. And these partitions are continuous in the sense that if you have a layer, so models consist of layers, and each layer is like an individual computing block.
Wow.
And each layer depends on its previous layer. So, you know, Llama, the new Llama had 196 layers, which is a lot, which means that in order to compute an inference on this model, you have to run through, you know, each of those 196 layers one by one. So you run through layer 1, and then you pass the output of layer 1 to layer 2, and then you pass the you run layer 2, and then you pass that to layer 3, et cetera, until you go through the whole model. And EXO in its current form, what it does is it just, you know, puts the first, let's say, 50 layers on one device, then the next 50 layers on the next device, and the next 50 layers on another device. And then the communication overhead of sending the outputs of each layer is actually quite low. Even for the latest Llama, it's like 100 kilobytes that you need to send. So every time you generate a token from the model, you'd be passing around 100 kilobytes times the number of devices that you have.
Wow.
So if you have 3 devices, then you're passing around 300 kilobytes every time you generate a token, which actually isn't that much, especially if it's over a local network. And so, yeah, like going back to your question about like, can you run it on the CPU? Like you can, and the current architecture is maybe not the best suited to that because it doesn't get very good utilization out of the compute.
I see.
Because with this current architecture, only one device is active at a time. But there's no reason why you can't, you know, utilize all the devices at once. You just need a slightly different architecture. And we have a prototype of that, very early prototype of just doing something called operator parallelism, which takes the individual operations in each layer, and instead of running them on a single device, it runs it over multiple devices at the same time.
Wow.
And it requires a little bit more synchronization. So you're not just sending 100 kilobytes around now, you're sending a bit more because you need to send around the actual, you know, oftentimes you need to send around the parameters now. And the parameters, like we said, are huge. But, you know, that can also improve. I mean, the simplest thing, so this black box, you know, of this black box model is basically doing a bunch of matrix multiplications when it really comes down to it. That's where most of the compute is going. And you know, there's ways you can split up a matrix multiplication into smaller matrix multiplications.
I see.
And that's one of the primitives you can use to start to parallelize the actual compute and use multiple devices at the same time. So I think CPUs will have a part to play. I think ideally, you know, we want to make EXO as accessible as possible. I think, you know, part of the reason why we started EXO is because we don't want to live in a world where these powerful models are controlled by a few companies.
That's right.
That can decide who has access, can decide what the models are trained on. You know, they make it so it's very hard to customize the models. They lock you in. And as we saw, you know, a week ago, ChatGPT was down for like a few hours, which is really annoying.
Crazy.
So you're a fan of this like doomsday scenario. Like, you know, if you do lose access to the models, I think the thought process that you have to play through is like, okay, how much am I relying on these models?
Yes.
And that's clearly, you know, something that's increasing over time. a few years ago, I was maybe not using any models at all, but now
Right.
I use models every day.
Yeah.
For a lot of things.
Yes.
For my day-to-day work, I'm using models to write software.
Yes.
I'm using it to ask questions. It's baked into a lot of apps that I'm using.
It
So-
feels like electricity. You know,
exactly.
like
It's that fundamental, right?
Yeah.
So then the question you have to ask yourself is, well, do I want to be so reliant on, these few companies and give them this level of control?
right.
And that's where EXO, we want it to be as accessible as possible, where the barrier of entry is as low as possible. And ideally you can just run this. It would be as simple as Dropbox. You can just run it on all your devices, and it will automatically get routed in the most optimal way using all the hardware that you have available, your phones, even Apple Watch, something, your laptops, desktops, GPUs, everything. And then you're not reliant on anyone. You're just, you're completely off the grid in the sense that you can run these models no matter what happens. I literally just, set this up in a couple minutes from, where I was staying. I just brought my two MacBooks over, literally didn't need anything. I don't need to call some API. They're just talking directly to each other.
Wow.
No reliance on any third party there. So, and part of that is CPU as well, because not everyone will have a powerful GPU. Not everyone's going to have a 128 gigabyte MacBook Pro.
That's right.
So there's two ends of the spectrum which we're interested in. One is the most basic hardware possible, like CPUs with maybe some slow memory, and we want that to work. And then on the other end of the spectrum, we've got like specialized chips, right? So going even further than GPUs, you've got like language model specific chips, LPUs, for example.
Right.
And we want to address both. And I think, you might have a world in a few years where every phone comes with an LPU, for example.
Yeah.
And in that case, you might be able to run a lot of these models just on one device.
That'd be cool. That'd be amazing. Yeah, I think that's what's really interesting. And for those who are just tuning in, kind of resetting here, Ronald had to kind of drop off and take care of some things on the. We just had him on the phone earlier, and thank you for tuning in. This is our weekly show we have every Friday, and today is a very, very special guest. So this is Alex Cheema, and you're one half of EXO Labs, right? And your other partner is
Mohammed Bayoumi.
Mohammed Bayoumi. So thank you, Mohammed. And he's currently right now in the UK, or?
Yeah, I think he's in Oxford right now in the UK.
Okay. So he's hanging out there, and we have Alex here in the Bay Area right now. Literally, I dragged him to my house. I was like, we got to do this video podcast because this is just really amazing. And I said, the people need to hear this, because what has been happening is that with open models, now that they're available and some of them are really big, there's this problem of trying to run them on your machines. And so you can't do it with one machine. So you may need two or so, or you may need more. And so what's great is that people have at an office, many people have machines, or just the fact that I could just call my friend and say, hey, let's go to a coffee shop and let's just do some like inference. let's play around with this ChatGPT model. And so there are different models that have released of various sizes, some requiring more memory than others, and some requiring not as many. And so what this means is that you can run these things locally on your computer, and then like your phone or any of your other devices can then, because it's running on the network, can also do that. And so we have a demonstration that's going to be coming up where these two guys are currently hooked up and they're running, is it CodeStrill model?
Right now they're just, they can run CodeStrill. They can run DeepSeek. Sorry,
yeah,
DeepSeek. They have Llama loaded up as well, Llama 3.1. So we can demo both. We can demo Llama 3.1. We can demo DeepSeek.
Yeah,
so we have them already.
Cool. Yes. So what basically happened earlier this week, for those who are just tuning in, is that the big model dropped. And there was this big drama because you were trying to get the model onto your devices, and it required all this crazy internet bandwidth that you didn't really have. And I just happened to have some. And so I came through with the actual weights of the model, like the 800 gigabytes.
Yeah. Also, before that, I just mentioned DeepSeek. I just want to give a big thank you and shout out to MZ Back. thank you so much for putting in that pull request with the refactor and DeepSeek. DeepSeek was something I wanted to support for a while. It's as far as I know, it's a mixture of experts architecture, which this would be the first mixture of expert on EXO.
Whoa.
So for those that don't know, mixture of experts is essentially a collection of multiple models that are good at different things. And when you run an inference, instead of just running through one model, you might run through, you select the best model and then you run through one or two or three of them.
Wow.
And yeah, like I just saw, when we got here that MZ Back had put in this pull request.
That's epic.
EXO is open source, so anyone can contribute. And I think this is the power of open source. It's just like, wake up one morning and there's, some cool new feature that's been added without me having to even do anything.
Amazing.
So far, like, it's basically just been me that's contributing most of the code, but now it's starting to become more of a community effort.
That's excellent.
And DeepSeek is actually quite a capable model for writing code. So let's say, you want to have a coding assistant while you're writing software, then you can use DeepSeek to basically streamline the whole development experience.
Wow.
I mean, personally, I use an IDE called Cursor.
Yes.
For all software that I write. And it speeds me up a lot. It helps me be way more productive. And but one of the things is, in the past, it's been down for me. And that's really annoying. So it'd be nice, until the models get really good, because DeepSeek is not quite as good as something like Claude for writing software right now.
Right.
But having this as a fallback is really valuable. So this is actually quite a big milestone, I think. It's basically the first significant open source contribution to EXO. And it's the first time that you can, realistically write software with EXO.
That's so cool.
So yeah, thanks MZ Back.
Yes.
I don't know what your actual name is. It says Anchen here on your GitHub, so maybe like this guy.
Yes, you could see. You could point at that camera there. Yeah. Anshin. Yes, that looks pretty good. Yeah, no, thank you for the contributions. I think it's really important. And for those who are just tuning in, if you're digging the stream on X, at the very bottom right, there's 3 little dots. And when you select that, there's an option to basically share the broadcast with your friends. So we invite you to share the broadcast with the friends because we're trying to get this message out there. It started off with this being fairly viral in terms of the posts that you posted. I actually was at your house when we got the weights loaded for the Lama model. And then
you came in clutch there. Otherwise, I wouldn't have been able to get it running that day for sure, because I was just sitting there trying to download the weights, but it was excruciatingly slow. The download speed was really bad. And it's, you need to download 800 gigabytes of data here.
And the whole world was trying to download it.
Yeah, everyone was trying to download it at the same time. Which I'm amazed that Hugging Face held up with that, actually. I'm not sure how much money they're burning by giving this for free, but it must be a lot.
Meta must be kind of like backdoor supporting, maybe. I don't know.
Maybe, yeah. I did hear a story recently that, Hugging Face were burning millions of dollars every week on, providing these models for free, but insanity. I don't know what the current status is on that.
Yeah, so...
But thanks to Hugging Face.
Thank you.
Also...
open source for the win. And big shout out to Prince Ganuma as well, who basically, I think he put the pull request, right, for...
so I can give a quick rundown of what happened on that day, because now a lot happened. My goal, I tweeted the day before, my goal for tomorrow is one thing. It's to get Llama 405B running on my MacBooks. And there were a lot of ups and downs that day, but we did get there in the end. So it started with, in the morning, Prince Kanuma, shout out to him as well. He's a big contributor to MLX, which is one of the open source libraries we're using for inference. He created a pull request on the MLX repo, which basically added support for the new Llama architecture, because they changed a couple things in terms of how you do the something called positional embeddings, which basically kind of keeps track of the order of tokens and how they kind of
so like when you have like the cat was chasing the mouse, the position of where the cat chasing and mouse is really important in these models. So if you have it in reverse, the mouse was chasing the cat. If you have that as an output and it's reversed, it's kind of, the positional embedding kind of keeps that order as part of one of its types of training things. So
so there was a small change that Meta had made with this new Llama release, which required writing about 50 lines of code to basically change how positional embeddings work. And people did this almost immediately in PyTorch because obviously the PyTorch developer community is huge, and it's maintained by Meta themselves.
That's right.
So this was basically available immediately. But all these other libraries like MLX, which is Apple's open source ML library that is maintained by Auni Hanun, shout out to him as well. He's the guy who's really spearheaded and wrote most of the code for MLX. Basically, MLX is a library that's specialized for Apple Silicon. So running neural networks, running models on Apple Silicon specifically. And it has features in there that, for example, are aware of some of the nuances of Apple hardware, like unified memory. And so whereas in PyTorch, you would have to, for example, copy data from the CPU to the GPU, you don't have to do that in MLX. So basically, Prince Kanuma put in this pull request to add support for the new Llama model to MLX. And then I was messaging him as like, hey, is this working now? And he was like, it kind of works.
Wow.
There's a few bugs. So, but he said it was his birthday.
Oh, that's
so
right.
he didn't really have access to he was on the go, so he didn't have access to his laptop. So then I picked up the pull request. And basically tested it on my machine, fixed a few things. And then Auni reviewed it really quickly because I messaged him.
Nice.
He reviewed it. He changed a few things as well.
Yeah.
There was a critical bug that I noticed last minute, which basically made it twice as slow as it should have been. So instead of getting out of the 8 billion parameter model, when I first tested it, it was getting 30 tokens per second.
Whoa.
And then I made this one line change, which basically, instead of every inference, every single token, it was calculating positional embeddings. It just did that at the start instead, just once in the initialization.
Yes.
And that one change got it from 30 tokens per second to 70 tokens per second.
Nice.
So that was and that turned out to be really important because what I realized later is this was non-linear in terms of the size of the model. So for the really large model, I was testing on the 8 billion parameter model, but because I was waiting for the other ones to download. I could obviously download the 8 billion one because that's only 16 gigabytes.
Right.
But the other ones were huge. For those, it would have been 10 times slower.
I see.
So this turned out to be just a last minute thing that I noticed that was a critical change that was needed to make it actually usable for the larger models.
Fantastic.
So then we put got that pull request merged. Auni merged it. He then very quickly published the new version of MLX, the MLX PyPy package, which is what is required for other people to consume MLX.
Okay, yes.
He published that to PyPy.
Yes.
And so then basically MLX, had support for the new Llama model from that point on.
Wow.
And then sort of the challenge after that was getting it to work with EXO. So now that it worked locally on one machine, you could run this small model with this new architecture. So there were, just to give some context, there were 3 variants of this model that were released. An 8 billion parameter variant,
Yes.
a 70 billion parameter variant, and a 405 billion parameter variant. And the 405 obviously was the most interesting. It's the newest, the other ones were basically incremental upgrades of the existing Llama 3 models. But the 405 billion, this was the first time that such a capable model had been open sourced.
I see.
So that was the real aim to run that model. And then it was a matter of just getting this to work in EXO. So EXO, it splits up the model so that you can run these larger models across multiple devices. You wouldn't be able to run the 405 billion parameter model on a single device with MLX. So then I basically spent few hours just sort of debugging a few things. I didn't expect things to break so much with running these larger models. There was a lot that worked for smaller models but didn't work for larger models because it'd never been tested on a model of this size.
That's right. So there's a lot of assumptions that are made because you get that for free and you kind of overlook them because of the speed. But now, because you have this larger model, kind of pushes the edges of where your bugs are.
Yes. And the annoying thing was that I had to kind of test with the 70 billion parameter model because I couldn't download the 405. So that's when I put out a tweet asking for help with, is anyone in the Bay Area downloading this model as well? Does anyone have a really fast internet speed or already have the weights downloaded so that, I can just go visit you in person and literally transfer the weights physically with, transfer it to my hard drive.
Right.
And then you at the time were also downloading the weights. So then you were like, I have a pretty fast internet connection. In a few hours, this should be done.
Right.
And then I was like, and then I told you my address and you were like, wait, this is right around the corner.
You're like up the street from me. Like, bro, come on.
So it couldn't have been more perfect.
Big shout out to Noddle Spike, who's out there. And he basically gave me the Hugging Face download script that allows me to run multiple threads. So that script actually helped out because initially I was actually downloading the script from Meta. And I was like, hey, is this the right model? And you're like, no, this is not the right model that you're downloading.
It was really confusing how they put the weights up because they also put out this, was it BF?
Yes. It was not the BF
one. It was MP6. They put out some MP16 version, which I still don't know exactly what that is. I thought it was mixed precision, which is quite a common thing to put out, where different parameters have different levels of precision. But this turned out to be something called like multi-parallel or something where to run distributed inference. And I was like, oh, maybe we can use this, but turns out that this was another thing that Aoni saved me on.
Sneakernet. Yeah, that's basically what we have to do.
Aoni told me last minute that you should download the FP16 one because that's the only one that MLX will support when you convert the weights.
I see.
So luckily he told me that because then you were downloading the wrong one.
Yes.
And then you had to switch halfway through to download this other one.
Right.
And then you managed to download it in a few hours, I think.
Here we go.
That was the hard drive that saved the day for us.
Yes.
You came over with the hard drive, transferred it over to my MacBook. Then I had to convert the weights from the format that they had them in to the MLX format.
Oh, that's right.
Which again was a bit stressful, and I was surprised it worked, to be honest, because I was converting them on one MacBook, which had 128 gigabytes of memory.
Oh.
So obviously 800 gigabytes of parameters wouldn't fit, but fortunately, the MLX guys had done some good work to make it compute lazily. So it didn't load everything all in at once. It did it like incrementally. Fantastic. And so you could load these giant models incrementally into memory. And then it converted. We split it up over, then I sent it to my other MacBook. So I had it in one MacBook, sent it to the other MacBook. And then, just like span up EXO. EXO had already worked on the 70 billion one. So it's like, okay, this is probably going to work. And then it just didn't work. I was putting stuff in and then the process was just being killed. So I was like, maybe it doesn't quite fit into memory on a single device. We might need to put it on the Mac Studio as well. I had a Mac Studio with more memory that we could then put it over 3 devices. But then randomly, we tried it again, just to make sure, to sanity check, and then it just worked. And we just, the first token that came out was an eye. So I couldn't tell if it was some visual bug. It was just like a line. I remember we were sitting there and it was just like, wait, is it working?
Right.
And because it was really slow as well. Initially, the model was just putting out one token every 5 seconds or something.
That's massive.
So we couldn't tell. And then it said, I, and then it was like, I'm.
I am.
And I was like, okay, yeah, this is actually working. And it's and then it just said, I am, because we asked it, who are you? And it said, I'm, what was it? Llama stands for something large language model meta
AI,
or something.
Large language meta
AI, something like that.
Yeah.
The acronym didn't quite make sense to me. I don't think it quite fits, but they forced that in just to make it say Llama, I think. But
It's Alive was one of those types of moments where wow.
Yeah, it was holy shit, it actually worked.
Yeah.
Then we had it running.
Yeah, huge shout out to everyone who's on right now. We have about 312 people on the stream right now, live watching.
Yeah, feel free to ask questions. Like, I want to take this opportunity to go a bit deeper on what we're doing, and just if anyone has any, questions that weren't answered by any of the tweets that we've put out so far, or the repo.
That's right.
Also, if anyone is interested in contributing, the code is fully open source. So you can, we've had about 5 pull requests come in today.
Sweet.
Which is really exciting because it means that, it's not just me working on this anymore. It's more of a community effort. And one pull request in particular that implements basically DeepSeek, which is a model that can do coding for you.
Yeah.
Which is really nice because now you can code without having to rely on ChatGPT or anything by MZBack and Shen. So thanks a lot for putting that in.
Awesome.
If you want to contribute, there's a list of bounties on the repo, which basically are just like, if you can complete these tasks, then you get like $100, $200, or $500.
Nice.
Like if you then contribute, then we're also hiring. So if there's any like cracked engineers out there who are interested in what we're doing, we want you. So take a look at the repo, see if you can, put in a pull request, and then, we can take it from there.
Let's go. Yeah, that's definitely really cool. So like Exo Labs, get on it if you haven't checked that out. So, GitHub, all you have to do is type in EXO Labs, right? And you should be able to pull up your repo. And
yeah, just check out just go into Twitter, twitter.com/exolabs_. It's a bit of an annoying handle. We didn't manage to get the Exolabs one yet.
Right.
But go there. Then there's a link to the GitHub. And yeah, there's a bunch of issues. Like I've created a lot of issues on there. Other people have created issues with bugs, with feature requests. There's around 50 issues now. So there's a lot of work that needs to be done. And yeah, a lot of exciting work as well. This is really pushing the frontier forward.
Wow.
For open source AI.
That's right. That's right.
So, for example, being able to, there's a bounty available for like being able to run Lava.
Wow.
Which is a vision language model. So, this would be the kind of thing that would enable you to do stuff like have a home, you could have your home security system.
Wow.
Which is plugged into Exo.
Wow.
And it gives you, it basically tells you what's going on. So, for example, you could ask it like, hey, did the delivery driver come this morning?
Yo.
And it could then run the model in a way that's fully private. So you're not sending your video data to ChatGPT or something, which is what a lot of people are doing right now. It's just staying on your own devices, 100% private. It works offline. You don't need internet access. And so like there's a bounty out there for that. Someone might have already claimed that one. So there's a list on the spreadsheet of just who is working on each bounty.
Is it Exo on iOS and Android as well?
So the Exo does work on iOS and Android in theory. Right now, the iOS and Android implementation are broken. So right now, it just works on Mac and Linux.
Okay.
But that's another thing that if someone wants to contribute, that would be great to just bring that implementation up to speed, because right now it's not ideal. We have 3 separate implementations of Exo. We have the Python implementation, we have the Swift implementation, and we have the Kotlin implementation. And that means that every time someone changes something in Python, it has to be updated 2 more times.
Wow.
Which means that these things often get out of sync. And so right now, Android and iOS have been left behind because we've been just fixing stuff like crazy the past few weeks. But yeah, like if there are any iOS or Android engineers out there who are interested in work on that, then either create an issue or just respond to one of the existing issues.
Yeah, I think it would be cool because what we've done so far is that we right now have Exo loaded up on the laptops right now, right? So you have these were actually the laptops you use for running that Lama 405.
Yeah, these are the exact same ones. So these are the same ones that ran the big Lama model the other day.
And so the typical scenario is like you have machines that are sitting at home connected to your network, and you have your phone, right? So your phone is with you, and so you want to tap into actually using, this type of inference. And so there's an app that we've started to use, and we found there's what's called Apollo, Apollo.
Yeah, it's really under the radar. There's not a lot of people talking about it. They have about 1,000 followers on Twitter, so you should definitely check them out though. Like, it's a really simple, nicely made app that allows you to set a custom endpoint for inference and basically run like a chatbot interface that you can also talk to with your own custom endpoint. So, and that endpoint can be XO as well, because XO provides a ChatGPT compatible endpoint. And that way you can basically talk to a chatbot using your own hardware on your phone.
That's
so
awesome.
I can demo.
Yeah. That'd be kind of cool.
It might make a bit more sense if we can
show like that camera there. So this is the.
So yeah, like I'm just loading up Apollo.
Yeah.
And
actually, you might be able to show this camera, and if you keep it by your eyes, then like I'll zoom in with the camera. Let me see if I can do that for you. Here we go. And then I'll zoom in just so it sees the interface there, and then to kind of put it back a little bit closer to you. Yeah. That looks pretty good. All right.
Okay. So I have Apollo loaded up.
Yeah, there you go.
This is using so this is talking to the two MacBooks that we have over there that are running XO, and we can just talk to it. So does anyone have a suggestion in the comments for what we should ask the model?
Let's see.
Is it real time or?
Yeah, this is real time. But there could be some delay. But you could just say, write me a game of Python, Snake in Python. Yeah.
Okay, let's give it microphone access. In theory, I should just be able to talk to it.
Yeah.
Write me a game of Snake in Python. Okay. I can see the XO is doing something.
Yeah, let's show you the servers over here. So back there, you can actually see the servers going like bonkers back there with those responses.
And so it's actually a long response. That's why it's not showing up immediately, because writing Snake in Python is quite a big task.
And you could flip the laptop to show that way. Yeah.
Okay, it looks like it isn't working for code, maybe?
Maybe it worked earlier. So like one of my examples, I think I was going to say.
Maybe we should just not use voice, because it might be an
see.
issue with voice. So if I just type, write me a game of Snake in Python.
Mm-hmm. And you could just point it to that camera there.
So yeah, that seems to be doing something now.
Very cool. That's awesome. Yeah, and streaming it in real time. That's awesome.
Yeah, so look like an issue with voice, maybe.
Yeah, that's kind of what it sounds like, actually.
Because, yeah, I never tried writing code with voice before.
Yeah, so basically what he's doing is he's using an app on his phone or his tablet and going to that endpoint. And with that, what it's doing is actually, because we're plugged into the local network, those two machines are now activated and running the language model.
Yeah, so I can ask it as well now, like, it set like the width of the game to 800. I can just say like, change the width to be 1000.
Let's go. Let's
do this live demo.
Yeah.
Here's the updated code with change to 1000. There you go. Width equals 1000.
Wow. You can put it closer to the camera. Yeah, so it kind of gets focused. There you go.
Yeah. So this is using the new Llama actually.
Oh wow.
So this is using Llama 3.1 8B. That's the default model that XO uses. And like Ray was saying, it's talking directly to the MacBook,
which is back
one
there.
of the MacBooks. So maybe this one here. And then that thing, it receives a request and then sends, messages to this other MacBook, and they collaborate on the inference together. So it's sort of like a ring.
That's cool.
The devices, like the way it works is like, they all compute a partition of the layers. Mm-hmm. And it works in a ring. So every token, it goes throughout the whole ring. Obviously here, the ring is only 2 devices. So it just goes you know, round between back and forth between them two. But if you can have 3 devices, you can have any number of devices. Someone, my favorite is a guy that's like, he just has like randomly, he has 23 Mac Minis lying around.
Wow.
Let me just pull up the picture because it's actually really...
Yeah, there was like a tweet someone where like...
Yeah.
So what's cool is like, as soon as you run EXO, it sees the other Macs and then it actually adds them to the whole inference thing. So that's amazing.
So yeah, this is the biggest setup that I've seen so far.
Whoa. And it still says that they're GPU port.
Yeah. So yeah, Mac Minis don't have the most powerful GPUs. It's a lot of memory though.
That's right.
So this would actually technically be enough to run Llama 405B.
Wow.
4-bit quantized.
That's amazing.
So this is my favorite. Like, this is just a guy from the community who ran. I don't know why he has this many Mac Minis sitting around, but it's a cool way to stress test sort of EXO, and a lot of issues have come out of this as well. Like, you know, one of the problems right now, if anyone is looking for a easy task to start with, is sort of downloading models in a way that's more smarter than just downloading the entire thing onto every device.
I see.
So right now, EXO downloads the entire model onto every single device, which just isn't necessary.
Right.
We would need basically a way to make these partitions that I mentioned sticky, in the sense that, you know, each device always computes the same partition. Because if you restart EXO right now, it will reinitialize all the partitions. And so instead of device 1 getting partition 1, device 1 might now get partition 2. So there's 2 things that would be required for this change. Number 1 is sticky sessions, so sticky partitions. And number 2 is basically downloading only that partition instead of the entire model. So this would be a really good first issue if anyone is looking for some like easy things to get started with. And there's an issue in the GitHub repo for this.
Oh, that's cool. So layer assignments per device, question mark.
There already is. So yeah, like just making that sticky. So right now there already is layer assignment per device. But the way it's done is, you can look at the code. It's called ring memory weighted partitioning strategy. And what it does is it weights the partition, so like the amount of layers that it puts on each device by the memory of each device. And then if there's 2, like, so it sorts by that. So, but then if there's 2 devices that have the same amount of memory, it will basically sort by the ID, the node ID it's called, of each device. And the node ID is generated randomly on every startup.
Okay.
So this is just a very specific thing to how EXO works. But basically, if you were going to implement this as your first issue, then what you should do is you should make it so that the ID is no longer random, but you can already specify it manually, but that's not very user friendly. If someone has to type in -- node ID, node 1, -- node ID, node 2, instead of that, it should just like, maybe you should just store a file with the last node ID, and just, if that file exists, then just use that. And that way, when it sorts all the partitions, it will always be the same order, rather than right now where it's like kind of random.
Yes. Yeah. That's really cool. And so this is just an example of like basically how these types of systems can be used to basically run in your house. I'll get you some water right here. Let's go.
Thanks.
But don't spill it again. So earlier we had a little bit of spillage of coffee on the devices, and we're back. Everything's good. We're running.
Does anyone have any questions?
Yeah.
I'm really keen to just ask questions from the community. Even if you think it's a dumb question, just go ahead. I mean, there's not that much information. Like the problem is most information about EXO is hidden in the repo. So if you're not technical, then it's really hard to sort of just understand what EXO is, and you know, we want to work on that as well. So that could be another thing that if someone wants to work on, just better documentation.
Got it.
Because a lot of community members have figured out all the nuances of EXO. Right now, there are a lot of nuances just because it's experimental software.
Right.
Eventually, we want it to be as simple as running Dropbox. So you just get this started on every machine, and then they automatically discover each other.
Wow.
And you can utilize all the hardware that's in your local cluster without having to do anything technical.
Yeah.
But right now, there's a lot of like
hand holding.
hand holding. I've put out a little bit of content around just, you know, I made basically the minimum set of instructions that you would need to get Exo started, and I did it in 60 seconds across 2 MacBooks from a fresh install. So it's pretty fast, but you still need a little bit of know-how. So Miguel asks, if you have a TinyGrad Linux box chained with a Mac, is the fallback to use TinyGrad? Yeah, that's another issue right now. So this is a really good question about the specific way the Exo works. Right now, if you run on a Mac, so one of the core ideas that I built into Exo from the very beginning is the ability to swap out the inference engine that's being used for computing inferences.
Sweet.
So instead of it being tied to, for example, PyTorch,
Yes.
you can basically swap out the inference engine to whatever is suited best to that specific hardware.
Ooh.
So if you're running on, for example, a Qualcomm, like an Android phone, then TinyGrad is really good. So TinyGrad is the fastest.
I see.
If you're running on NVIDIA H100s, then PyTorch is the best. If you're running on Apple Silicon, then MLX is the best. In Exo, there's a concept of an inference engine, which is just an abstract, thing. It's just an interface. So you can plug in different inference engines that are specialized for different things. And the question he's asking there, Miguel is asking, is basically, let's say I have a MacBook and a Linux box. Now, is it compatible that the MacBook is using MLX and the Linux box is using TinyGrad?
That's right.
And the answer there is yes and no. So yes, in the sense that I think this is possible to do. It doesn't work right now because the version of the model that MLX is using and the version of the model that TinyGrad is using is different.
Okay.
But there's no reason why, in my mind, why this wouldn't work because of the nature of these models. They're as long as the implementations are compatible,
right,
it should work. Right now, the workaround is just to run TinyGrad on every device. So even if you're running on Apple Silicon, you would just override the inference engine, which you can pass in as a parameter to use TinyGrad. And that way it should work. That way it works. So you can have a Linux box, which is running on an NVIDIA GPU, which is running TinyGrad. And then you would have your MacBook, which is also running TinyGrad. And then should just work. They can combine the compute and the memory and everything, and it just works.
That's pretty cool. Yeah, and so for those who are just tuning in, we're basically kind of going over the 2 MacBooks is all you need. And there's a lot of people who had a lot of questions about what the setup is, what's the config, how do you get started, and then getting that type of thing. But then going a little bit deeper, it's for me, the question I had was how are you able to get first this inference thing figured out, right? When you have multiple computers, is adding 5, 10 computers to this whole thing make it better, or what is going to improve if I get more Macs, right? Because if I'm a IT person, it's let's just throw more money at it, So I want to really run this because I believe in this future.
So the current state of Exo is that there is one partitioning strategy, and there is one way of running inference, which is essentially splitting up the model into partitions. And the main benefit of this is the ability to run models larger than would fit into memory on a single device. So let's say, for example, you had one MacBook with 128 gigabytes of memory. If you wanted to run Lama, this is the maximum spec'd out MacBook that you can get. If you wanted to run the latest Lama 405B, even 4-bit quantized, you can do it. Although, you can do it, and the way you would do it is it's something called offloading. So basically what you do is you load the model incrementally from disk into GPU memory.
I see.
So you would first load the first 100 gigabytes of the model, run inference on that, and then load the next 100 gigabytes of the model, run inference on that.
It's you're sliding across.
Yes, sliding across. But that means, at the minimum, you have to move 100 gigabytes around every token. Every single token, you have to move 100 gigabytes into memory.
Wow.
And, moving stuff from disk, even on these MacBooks, is very slow.
That's right.
So, there's a nice picture in one of the papers Apple put out recently called LLM in a Flash, which shows you the different memory bandwidth bottlenecks. And I think the SSD, they basically said it's around 1 gigabytes per second. So you
okay.
would wait 100 seconds
Oh my
on every
gosh.
token just to move
Wow.
it from disk to GPU memory.
I
So
see.
it's just infeasible. So comparing to that, XO is, more than 100 times faster because XO keeps the model hot in memory across all your devices instead of having to load it from disk. And that way, it's way, 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 way faster. And yeah, it's just infeasible to run large models with offloading. So it's the only way to run large models on consumer hardware right now.
I see. And so what was the breakthrough that kind of enabled you to discover that this was possible, like number one, right? Like, how did you kind of discover this, or did you get inspired, or like, what was it kind of led you down this path? Like, hey, we can do this. Maybe I could do it in this implementation, and kind of like why you chose this specific.
Yeah, initially when I had the idea, it was very the reception I got was very skeptical because it sounds like a fake idea. It sounds like something that shouldn't be possible. It's like so there's this meme of like the left curve and the right curve, and this seems like about the most left curve idea you could come up with. It's like, hey, my phone is not powerful enough to run this model. Can I just combine it with my friend's phone?
Right. Yeah.
Right?
Yeah. It's like
it
totally.
it sounds like this is just,
And for those who aren't familiar with the meme, basically, it's like it's literally like this graph that goes like, or this like little line, and it's like the new entrant person, and then there's like the middle section where it's like where most of the people kind of think, and then there's like the expert level. And what ends up happening is usually the new person and the expert level are kind of at the same like idea as far as like how they come to the idea and they figure out it's feasible. And the people in the middle who are like the mainstream audience is like most everyone in the world generally has it wrong, and they're like overcomplicating it. And so in this case, you're just like, yeah, well, how come I can't just run everything on my phone? Yeah, that's the that's the meme.
So XO is very, like, as an idea, it's very much here. It seems like, something that you would come up with.
Yeah, like pie in the sky. Yeah,
like,
type of thing. Yeah, that's so fun.
But it turns out it checks out. So it's one of those ideas that sounds crazy, sounds like it would never work. But when you do the math, and I remember doing the math on this, and I was actually quite surprised. It checks out. And then the first thing I did is just some initial research on what's already out there.
Interesting.
And there was this great paper called Petals, which is one of the early PETALS, Petals.
Petals.
It's and I actually randomly just met the author of this paper the other week, Alexander.
Oh, let's go.
That's what happens when you're in the Bay Area. You just randomly meet these people.
That's right.
He's at OpenAI now, and
closed AI. It's our secret.
But yeah, this paper was the most memorable one that I read that was inspired a lot of the ideas in XO. I believe, Petals, I think, uses a master worker architecture, which is something that I moved away from with XO. So I didn't want to have this thing where, there's one master and then a bunch of workers.
I see.
Which I think is just it's a less robust architecture. It's also single point of failure. If the master goes down, then everything goes down. And it's also like not the best architecture in terms of if you're really optimizing for performance, you want to avoid as many hops over the network as possible. And if you have one master and a bunch of workers that the master is talking to, then now every time you do compute part of the model, the master has to go to the worker and get a response back. And then the master has to go to the next worker and get a response back.
Wow.
Whereas with XO, it's just a ring. So every node is equal in the sense that there's no master. They're just all XO nodes. Wow. And so they all talk to each other directly. And that reduces, the latency by 2 times. Because
interesting.
approximately 2 times. It could be even more because the connections between individual devices might be even faster than the connection between the master and the workers.
I see.
And that was one of the big architectural changes from Petals. But reading that paper was really useful. It inspired a lot of the stuff that we did. And then from there, it was just like, I had some just ideas of how would I do this in the way that is, keeping in mind that we want this to run on any kind of hardware in the future.
Right. Yeah.
We want this to be as accessible as possible. We don't want there to be any configuration and setup. It should just be as simple as running Dropbox. And that's where the automatic device discovery was one of the instrumental features. The device equality, like I mentioned, where there's no master or anything like that. And then, we built a prototype very quickly, and then put out a video, and it went insanely viral. It got like 1.3 million views.
You're just on fire.
That was about a month ago with the first prototype, and
Wow.
that was running across a few MacBooks, an iPad, an iPhone.
Oh, okay.
And it was just super hacked together, but the feedback was really good. We got a lot of really good insights from just, all the feedback that we got. And then work started on the proper open source repo that was this is now the proper version which people can contribute to. It's written in a way that's modular in the sense you can plug in different inference engines and stuff like that. It's not just hacked together. Then we open sourced it. We didn't when we open sourced it, it blew up unexpectedly, just organically.
Yes.
So and we didn't want it to, because the initial idea with just putting out the repo and just saying, hey, here's the repo,
Right.
was maybe a few people from the community latch onto it and they start they use it, work on it, and then we can just iterate and get feedback from those individuals.
Yeah.
And what ended up happening was that, went viral again, and someone also posted it on Hacker News. We didn't even post it on Hacker News.
Interesting.
And it was on the front page for a whole day. Wow. So it was trending on there, and then thousands of GitHub stars came in. It just loads of people looking at it, loads of people cloning the repo.
Wow.
There was just a lot of stuff that surprised us as well. Some people were cloning this 100 times. There was a huge spike in the number of GitHub clones.
Because they got to get it distributed on all their machines, right? The guy with 100.
Yeah, exactly. So for that guy, he's got to clone the repo 23 times over every device.
Let's see.
Miguel has another question. So if 405B was trained on 16K H100s and Meta has 300K and Elon has his 100K, it's a very convoluted question. I'll try and simplify it. So basically saying, it's just a comment about basically, what's happening. The trend in the world is that you've got these few companies that are buying more and more GPUs, and Elon just bought 100K H100s or something.
That's right.
And basically there's no force against this right now. This trend of just more and more centralization, bigger and bigger GPU clusters, that is where all the big models are being created. So
I see.
Potentially down the line, I think what he's saying is that EXO could also be used for training. Right now, there's no training support in EXO, and it's not something that we're focused on at all.
It's good to know.
There is, but it is a possibility in the future. And Prime Intellect put out something recently, OpenDeLoco. It was a DeepMind paper. They implemented this across a bunch of H100s distributed globally.
Wow.
And I think the overhead was only 40% or something. I'm not sure what the exact number was, but it wasn't huge, which means, this is and they trained quite a big model, I think. It was more than 1 billion parameters.
Wow.
So potentially in the future, you might actually have the largest models being trained on in a distributed way instead of just in one giant data center with NV-linked NVIDIA GPUs.
Okay.
But that's not something that we're so much focused on. But if you want to work on that, the EXO architecture, you should be able to build that into the library quite easily if you really wanted to. So if someone wants to work on that, then we can also I think that's definitely worth a big bounty, at least $500 if someone can implement just a basic proof of concept of training on EXO. And then I think the first step might be just fine tuning.
Right.
So, if you want fine tuning, for people that don't know, is basically a way of just specializing a model to a particular set of data. And this is really useful, for example, for personalizing models. So, all these, the Llama model that was put out is quite generic in the sense that everyone is downloading the same set of weights.
That's right.
But there might be slight differences in how you use the model. Maybe you talk to it in a slightly different way. Maybe, you prefer responses that are very short or something like that. And in that sense, you can fine tune the model to have your own personalized version that works in the way that you want.
Right.
And I think that might be the first step for doing training on EXO is just like get fine tuning working. Fine tuning in a way that can use all the hardware that you have in your EXO cluster instead of it just running on one device. Because if you wanted to do let's say, for example, you fine tuned on all your files that are on your PC.
That's pretty cool.
So that the model knows about, all your documents and, maybe even knows about your, I don't know, you could even feed it in your location history or something.
Yeah.
And then, because it's all private on your own devices,
right.
You can start to do stuff like this. You wouldn't want to send that to ChatGPT, but
Right.
here you could have it know, where you are and, what you do, what your schedule is like and stuff like that. That might actually take, a really long time to fine tune on just one device.
Interesting. Yes.
So that's a case where instead of it taking a day on one device, it could take a few minutes or something like that just by using all the hardware that you have available.
Yes.
So that would be probably the good first step. Instead of training foundation models, I think right now EXO in its current form would be more suited to something like fine tuning.
Cool. Yeah, I also wanted to kind of, there's been some new people who joined the stream. We have right around 372 people who have joined. So thank you so much for joining in. Definitely appreciate that. Got to play some music, of course, to get the vibe going. So this has just been an amazing talk, and we're just kind of asking questions to the audience. So who do we have here today? We have Alex Cheema from one half of EXO Labs. And basically the goal here is to run Inference on all of your computers that you have available. So you can just load these models and then have them run locally and private and so forth. So one of the advantages that we were showing in a demo earlier is how your phone at home, my phone was able to talk to his two computers. Instead of going to ChatGPT, all private, all within my network, nothing exchanges, going outside to the external world. And then another thing we talked about earlier was about how if you have a security camera and those images, you can have this running in the background. And if somebody gets the Lama model, which is the thing that analyzes those images, you can have it search for various things, or you can ask questions. When does my wife come home? When does this come home? Or when does this show up? Hey, is there something going on in my house? And just asking general questions. You're like, yeah, your kid is going back and forth and he's hitting his head against the wall every time at 3:00. You're like, that explains a lot.
And you might not want to send that video to OpenAI, right?
That's right. Yes.
Or Google.
Yeah. So basically what EXO and what Alex and Mohammed or Mo and the open source community has been able to do is to provide an avenue for you to run this stuff locally at home. So this basically can sit on your local network. You have the models on the machines, and then you have APIs that go against it. So right now it requires a little bit of advanced knowledge. If you know some Python, you can kind of get in there. It's not yet ready, but the goal is to basically have this running. So it's just like a one-stop drop. You could just put it in like the way you install Dropbox to exchange files would be a similar way that you just install this app and then all your other devices would see it. And so we're basically getting the sneak peek preview and a chance to talk to Alex here. And so if you have any questions, since this is a live
this
stream.
is like pre-alpha.
Yes. Yeah.
Very experimental right now, but yeah, the goal is to make this as easy as running Dropbox, and you can just have your own personal AI cluster that is private. It works offline and is free.
That's just amazing. So definitely take this opportunity, and definitely have appreciated everyone who's been able to ask questions, because we are really at the tip of the iceberg. And so all you have to do is just drop the questions below, and then they'll be featured and so forth.
Yeah, about EXO, about distributed inference, about
Yeah, has anyone
decentralized AI.
had a chance to try this yet? You know, if you had any chance to try it, what things were you running into? Maybe we can answer some questions to help you get started, because this is still like very early alpha stage. And so if you're trying to try it, or if you haven't tried it, or it's too confusing, or you ran into something, just let us know right now, and we can help you. Because
there's 374 people, but no one is asking any questions. So come on, there must be some questions with 374 of you.
Some people,
even if you think it's a dumb question, just
yeah. You know what I think it is? I'll tell you a secret. All right, tune in, kids. I think it's your accent. I think people get intimidated because you sound so like intelligent, and they're just like, there's no way I could speak to
like
this.
The place I come from in the UK is generally the stereotype is that it's stupid people have this accent. So I'm surprised that you associate that with intelligence.
Well, as an American, I think it was really funny because when I worked at Apple, I would always love the keynotes when Johnny Ive was speaking, and like he just had this brilliant way of expressing, you know, just I could have this guy narrate my entire life, you know. And I think a lot of US people would like hear the accent are like, wow, this is like, you know, it just sounds very mesmerizing and it's pretty funny. And so just jokingly kind of saying this to get people to just ask questions. Yeah, we're not here. We can help out. You know, it's not really about sounding dumb. It's really here to learn and to bring to you this. And so we have a weekly show, myself and Ronald Monarch. Ronald had to drop off the call. It's called the AI Tech Salon, and he's currently remote. And so we try to do a live stream every week. And so today, you know, we have a founder here and has basically been breaking the internet this past week with hooking up these two MacBooks to run the largest model possible. And this is unlocking, you know, just a whole set of scenarios that no longer require like the big companies to be in between seeking knowledge and doing things. And we haven't even really talked about like culturally what's going to happen as this is capable to run, and as these machines continue to get better, where like imagine being able to just run this on one machine, right? But there are other countries like in Africa, there's other countries like in other parts of the world where you know, there's no internet connection. But if you bring over like a hard drive full of weights and put them on those machines and start running, a local tribe can start now having access to information they never had before. They can start solving problems. They can start asking questions about various things, you know, solve problems like even take photographs and maybe do some type of inference with the photographs, and just unlock kids' curiosity about the universe. And also app development. So you can make an app that can be running on your phone that just talks to your local cluster and get some information back. So there's just a lot of possibilities here, which is really, really cool. And this is totally unlocked here by Exo Labs. We have some questions streaming in here. So says, I know some folks here. Let's get some good questions. I can't be the only one. Yes, Miguel, thank you so much for definitely accelerating here and always kind of dropping in. So I'm just a big fan of Alex Cheema. That's really cool. Thank you for that. I appreciate the love here. Here's a question. What was the breakthrough to build Exo Labs? Was there any breakthrough, or is it that you just thought of a solution probably that others didn't?
There's no single breakthrough. It's a combination of many, many ideas coming together. And I think, like I said, with the Petals paper, there was already a simple version of this working. It just, you know, there was some architectural decisions that were made in that. I mean, it was more of a proof of concept that made it inaccessible and not really, you know, it wasn't like a thing that consumers would run on their own hardware. It was more of a research tool to help, you know, run larger models, you know, for researchers and also experiment with those larger models. So Exo in its current form is really just culmination of a lot of different ideas packaged together in a product that is accessible and easy to run.
That's really cool. Yeah, that's yeah. And
I mean, one of the core things, if you want to call it a breakthrough, is just sort of how the model splitting works. But that idea was already out there, so I wouldn't really call it a breakthrough.
I see.
Which is what it's the thing that I described earlier, which is sort of just partitioning the model into continuous partitions that each run on individual devices.
Got it. And so, what are some of like the most important pieces to like that you're seeing right now to make the model faster and inference? Because right now, when you're trying to run these really large models and the machines are barely capable, it takes quite a bit of effort to run. And so, what are some of the first optimizations you're seeing right now that y'all need to fix?
Yeah, so like I mentioned earlier, the main benefit of EXO right now is to run models that are larger than would fit on a single device. And you don't necessarily get to high device utilization with EXO right now because only one device is active at a time, which means there's a lot of room for improvement as far as latency and throughput is concerned. And, you know, one of the first things to do there is just instead of one device being active at a time, all the devices are always active at all times.
Wow.
And there's many ways of doing that. But the general area there is called tensor parallelism. And then a subset of that is like operator parallelism. And the idea is instead of, you know, just naively splitting up the model into these partitions, you parallelize the individual operations that are happening in the neural network.
Yes.
And so one example of that is taking a matrix multiplication, and there's a lot of matrix multiplications that are happening in something like Llama, and you decompose that matrix multiplication into multiple smaller matrix multiplications. And there's a number of ways of decomposing matrix multiplications.
Right.
It's a very well understood thing. That's one simple way to start. If anyone wants to work on that, the code is open source. It should be quite simple to get into that, and you can create an issue. We can also discuss it over an issue, exactly how to do that, brainstorm a bit. That's, I think, the first step, just to, you know, really getting the most juice out of all your devices.
Got it.
This is like the most naive, simple way to start. There's so much that we can do. We can also, you know, another thing I'll just quickly mention is sort of optimizing how much of, you know, what runs where. So right now it's super naive. You can look at the code. It's like we just distribute the model proportional to how much memory each device has. But it doesn't take into account, you know, the network, like the latency between each device, the amount of flops that each device has, the memory bandwidth of each device, the latency, all this stuff.
I see.
And that would improve it a lot as well. Like, you know, right now, if I put my Mac Studio with 192 gigabytes of memory into the mix, then that's going to receive almost all of the model because it's so much memory.
That's right.
But it's not necessarily the best way to split up the computation. It's just that it has a really lot of memory. Is there a question from Miguel here as well?
Yes. He saw your participation at the AGI house. So you got the Mac Minis running on the cluster via Thunderbolt with linear scaling. So how would that play a role in EXO and able to mix and match terabyte clustered studios with wireless nodes?
Yeah, a few people have asked this. A lot of people really liked the Mac Mini cluster that George Hotz from TinyGrad helped me with at the AGI house. So there was a hackathon that happened at the AGI house a few weeks ago. Really bunch of like very talented hackers there, and George Hotz was there. Imad also gave a talk there virtually. It was a really cool event. Thanks to AGI House SF and Kyle for organizing that. And what I did is I built a Mac Mini cluster for training using TinyGrad.
Wow.
And it won first place at the hackathon. Big part, you know, of that was the help that George gave me, because obviously he's the author of the TinyGrad repo, and he knows the ins and outs of that. So I could just ask him questions and he would immediately, you know what to do.
Wow.
So that made it possible to do in just 6 hours. It was that I got this working.
Oh my gosh.
So the idea here was I had 4 Mac Minis. Each one of them had 8 gigabytes of memory. And I wanted to... So I had realized... Okay, let me tell the full story, because this is actually quite an interesting story.
Sit down, kids.
So it all started with this viral tweet. So we put out this tweet with, you know, a bunch of MacBooks, iPad, iPhone that were collaborating on an inference. And this got 1.3 million views. It blew up. And one of the really cool things that happened with this tweet was Andrej Karpathy, one of the founders of OpenAI. He commented on the tweet and semi-sarcastically said, you know, he put a picture of a bunch of Mac Minis in a data center, and he was like, what was it again? It was like, is this what peak performance looks like?
Oh, wow. Wow.
Which is kind of sarcastic in the sense that he was like, oh, like on one end he's saying, well, the Mac Minis are actually useful and they can be used for training. Because also in the picture, these Mac Minis were connected by cables, physical cables.
Yeah.
On the other end, he's just, jesting. He's just saying like, this is dumb on one end. But then I decided to take it literally.
Nice.
So
that's
then
that same meme where you're like, oh yeah, this is a good idea.
Yeah, maybe in this case, the left curve thing was also the right curve thing.
Let's go.
So then what I did is at the same time, MLX were working on something called MLX Distributed, which is a new package in MLX that Aoni and co were working on, which in theory allowed you to do this. So I got a simple version of that working.
Interesting.
It didn't do training, but it just like connected the Mac Minis over Thunderbolt.
Yes.
And they managed to send tensors between each other, but it wasn't really training.
Gotcha.
It was just an experiment. I posted a picture on Twitter. It also got quite a lot of attention.
Wow.
People seem to really like it.
Huh.
And then I did some more research and I realized like, wait, maybe Carpathy is onto something here because Mac Minis have Thunderbolt 4 can support the latest ones. That supports 40 gigabit per second interconnect between Mac Minis, which is quite a lot. It's like 1/10 of a NV link.
Wow.
Which is it's only one order of magnitude off. It's not like it's what I thought was, which was like 3 or 4 orders of magnitude off.
Yes.
So then I went to this hackathon at the AGI house and I brought my Mac Minis with me thinking like, okay, I'm going to do something with these Mac Minis.
That's hilarious.
And then I arrived a bit early and turned out that like George was just sitting there on his own.
Wow.
When I arrived. So I chatted to him for like half an hour about like, hey, I've got these Mac Minis, what should I do? And it was like, can I run training on them? And he was like, wait, yeah, like TinyGrad actually has, this should be easy in TinyGrad. So I struggled with MLX a little bit.
Whoa.
He was like, well, TinyGrad has, basically these really nice abstractions for doing sharding of tensors over multiple devices.
Wow.
And right now, usually how that works is in TinyGrad is you have multiple GPUs that sit on the same device.
Yes.
And basically like, you're sending commands to each of these devices, but they're all on the same board, right? But then he showed me this pull request or this like branch of the repo that this other guy that works at TinyGrad called Woe's Parrot had worked on, which was just an experiment that instead of talking to a physical GPU on the same board, it talks to a TCP socket.
Oh.
And that on the other receiving end of that TCP socket can be anything.
That's interesting.
So that could be another device that's running TinyGrad.
So we can back this up a little bit. So when you're writing to things, you can basically write into like, whatever the substrate is or whatever the thing you're working with. And if it thinks it's writing into like a physical property of some sort, then you can basically say, hey, let's just write into this like TCP socket. And then like that's something that the Woz Parrot kind of made available.
Yeah, so TinyGrad has this concept of a command queue, and you queue a bunch of commands that are very simple things, simple operations. Like for example, it might be moving a tensor between, in memory, or it might be an addition or a multiplication. And, TinyGrad has about 20 of these operations. So it's quite minimal because PyTorch has a lot more. It has more than 100 different operations. It's one of the nice things about TinyGrad is they really reduce things down to, a very small set of operations that can do basically anything. They can do convolutions, whatever you want. And so this basically made it so that, this concept of a device that takes commands from the command queue and executes them. Well, that device, Woe's Parrot called it a remote device. And that remote device took commands from the command queue and sent them over a TCP socket. And then on the receiving end can be anything, right?
Interesting.
So then with this idea, what I did is I basically made that work for Mac Minis so that you can essentially talk over Thunderbolt, because Apple have done a really good job. Props to Apple for the way they implemented Thunderbolt 4. If you connect to Apple devices with Thunderbolt 4, you basically get an IP address that you can talk to, just like you would talk to any other device that's over a local network. And then it's just a matter of running TinyGuard on each of these Mac Minis. So then you basically like configure it so that each Mac Mini can talk to every other Mac Mini. And then as far as TinyGuard is concerned, because the layer of abstraction that it works at is like it's a bit higher than like PyTorch, for example, where you're just interacting with these devices.
Yeah.
So then now you just plug in your remote device and it works. It just works.
Wow.
So I was actually really surprised, because George was like really confident that like, yeah, you could do this in 6 hours.
Wow.
Like you can do this in a day. And it actually, like we ran into some issues at the end. So by the time I demoed it, it didn't actually work across all the Mac Minis. It only worked across some of them because there were some compiler issues. Basically the version of Mac OS that was running on each device was a bit different.
That's right.
And so because it's sending TinyGuard sends code over the network, and then each device runs that code.
Yes.
Now the issue there was like if they're running slightly different versions of the compiler, then they're running different code at the end of the day, so it's incompatible. But then afterwards, the day after, I just updated everything to the latest Mac OS and it just worked.
Oh, fantastic!
But maybe we can pull up a picture as well of just like the cluster because it's actually quite cool. But at the end, what I had was distributed training running across 4 Mac Minis that are connected over Thunderbolt, and it could train any model you want that TinyGuard supports.
The water, make sure you don't spill it there with excitement. Yes. And then you can show that camera over there.
Yeah, let me just pull it up.
I'll grab this water.
Thanks. Don't want another accident.
Yes, yeah. So that's interesting. That's incredible. I mean, so this picture like went viral again. I feel like everything you post just goes viral, and that was like the setup. Wow. 4 Mac Minis are all you need.
Yeah, and 40 gigabits per second is decent. Like it was, it's decent, but like I think one of the assumptions kind of built into TinyGuard is that you have these really high speed interconnects between your devices. Because obviously, if you have a bunch of GPUs on the same board that are
for sure
NV-linked or something, then the interconnect is really fast. So for example, I think there's some so it was quite slow to train stuff. And it was, I think one of the reasons is TinyGuard does a lot of things sequentially, but I don't think it has to. So I think I'm speculating a bit because I only spent like a day on this, so I don't know all the intricacies. But I think my hypothesis is that this can be made way faster by just breaking some of the assumptions that are built in terms of doing operations sequentially, and TinyGuard is really nice for this kind of stuff. So it should be not even that hard. It's only 5,000 lines of code, the core library, which is really impressive because if you look at PyTorch, and if you look at the whole of PyTorch with all the kernels and everything, it's more than 1 million lines of code.
That's crazy.
And if you download the binary for like PyTorch, for example, it's like almost a gigabyte, I think. Whereas 5,000 lines of code is maybe on the order of 100 kilobytes or something.
That's crazy.
So it's like orders of magnitude, like
tiny.
2-3 orders of magnitude bigger than TinyGuard is.
Wow.
And one of the other nice things about TinyGuard is that it operates on these operation DAGs. So like I said, there's about 20 operations in TinyGuard, and the way it works is, you have some high-level computation that you want to do.
Yeah.
It then compiles that down to a DAG, a directed acyclic graph of all these 20 primitive operations. And then what it does is it tries to find better graphs, because there's multiple ways of representing the same computation using these 20 operations.
Got it.
It runs a search on finding, and recently George implemented, I saw a tweet, he implemented Monte Carlo tree search to do this.
Interesting.
And it finds the most efficient kernels to run this particular operation. And the code for that, I also took a quick look at it. It's called like search.py. It's really small. So you can actually just read that in one go and understand what's going on.
That's
also the really nice thing. You can't do that with PyTorch. You can't just go into PyTorch and just understand what's going on. There's too many layers, too much code.
Yeah. You can't even drop it into like a language model and say, hey.
No, it's just too much. I mean, yeah, the context windows are getting bigger, but it's it's too much.
So if you had to like ask a question to Andre Kaparthi, like, have you met him at all?
No, he only tweeted. He only commented on one of those tweets, and he liked a load of stuff that we've put out. So he maybe knows roughly what we're doing.
I see. Well, what would you ask him? Like right now, because you're trying to solve some problems, you're trying to do different things. Like, what would you ask him? Publicly. Right? Because like that's what people are listening to right now. They're just like, because I feel like,
I mean, I could go the more technical angle, or just, you know, he's going the educational path, right? So he started a new company that's focused on education. So maybe the question to ask there, so one thing I really respect about Andre Karpathy is obviously an extremely talented engineer and AI researcher, but at the same time, he's a very good communicator. He's an exceptional communicator, and he's a very good teacher. So he can take this insanely, you know, complex idea of running an LLM, for example, and compress that into a 1-hour video where he walks you through how this works from first principles. Right. I really like his style of doing that. So maybe the question I would ask is just, you know, how can we better communicate and distribute this idea of what we're trying to build, package it up in a nice way that is easily consumable. Because he talks about building and I think it's building and distributing, something like that. And they're kind of like two independent things, right? Like, you know, we could build this crazy library that does all these things, but if we don't do a good job at distributing it and communicating what it is, then it's useless.
If you build it, no one will come.
Yeah. So, and I think, he also saw something he said recently about, you know, one of the insights for him that really clicked was, I think when he first put out the GPT from scratch repo a long time ago, and it didn't really get much attention. It got some stars, few people saw it, but not many people were really engaging with it. And then he put out the video with it, which it's the same thing. The repo didn't change, but he's just got a nicely packaged, easily consumable piece of content that walks people through it, that allows it to achieve mass distribution, right? So there's these two stages to everything. There's the building and then there's distributing. And I think I would just ask, like, okay, how can we do a better job at EXO with, you know, packaging it up and distributing what we're doing?
Interesting. Wow. And then what technical questions would you ask him? Because I feel like you have, you know, you're running into some problems and you're running into different things. You have a lot of different technical challenges. And so, you know, somebody who's had that much experience, I'm just kind of curious what you're thinking and what you would want to learn from him. Because I feel like, you know, you're really in it, you know?
Yeah, maybe the biggest blind spot for me is maybe like distributed training, which obviously is a huge opportunity. And if we really want to break the monopolies of AI, then you want to also democratize training. So we're democratizing inference right now, but training is a core component of, you know, the AI of today. The current model is that you train these giant models on giant GPU clusters and then distribute that. And that's something that EXO isn't really addressing right now. So maybe just ask him the question of, you know, where do you see training going? Do you see decentralized distributed training as something that's viable? Do you have any insights in how we would get large models, like being able to train large models on consumer hardware in a distributed way?
Interesting. And so kind of stepping back a little bit, trying to understand the landscape, maybe I always like to see like where we are in the arc of things, and like kind of like to famous Wayne Gretzky's quote that Steve Jobs famously quotes, you know, skate to where the puck is going.
Yeah.
And so AI has come into the mix. you get a bunch of stuff, you put it in, and something else comes out at the other end, kind of random, And then before that, CPUs were like, okay, you give a computer instructions, very explicit instructions, and the computer will do exactly what you tell it to do. And so like we're kind of, for me, it feels like we're shifting into a new era of like, put stuff in, random stuff out, and there's so many different problems to tackle. What is coming to light to me is like how much that you can utilize this output to provide economic value, be it replacing an engineer, augmenting an engineer to do better work, augmenting groups of people, workflows, and so forth. And so right now you're tackling and focused on the problem, which is inference, which is like, how do you get that economic output to people faster, as fast as possible? Where do you see that kind of going in the next like 2 years or so? Because I feel like every year is almost like 7 years in AI. It just kind of moves extremely fast, and just kind of curious to where you're seeing that.
Yeah, the biggest paradigm shift that we are also, it's the core thesis of EXO, is that AI inference is going to move from a cloud paradigm to an edge paradigm. So most inference, instead of running on giant GPU clusters in the cloud, it's going to run on the edge. And the main benefits there are, it's private.
I see, yes.
It works offline. You don't need internet access. And it's free as well. If you already have the hardware, like I already have these MacBooks that have extremely capable hardware that can run the biggest open source models, the most capable open source models.
Wow.
Why should I pay like a subscription? Or even if I'm an enterprise, paying per request,
right?
Instead of just using my own hardware. So this is the main paradigm shift. You mentioned two things in the context of developers. So obviously I'm a developer. I use AI tools every day to write software. And you said two things. You said either replacing engineers or augmenting them.
Right.
And I think there's a interesting distinction there, and a very important distinction. I think the evidence, as far as I've seen so far, suggests that replacing is less of an issue. It's more, the biggest use case for AI for development right now is augmenting. And what that means is that it's not like if you don't know how to code, you can suddenly code. You can maybe do some toy examples and get it to generate a snake game or something, but you're not going to be writing production applications. I think the main shift we're seeing is just augmenting really good developers to be even better and to be even faster, even more productive. There was a viral Reddit thing that recently about this Claude engineer, right? Like this guy who is using Claude to run his startup, and he's like, I'm 100 times more productive because of Claude. Right? So he's a really good founder. He would probably be really good without AI, but he's just being augmented. He's being, it's just putting it on steroids. So it means if you're not very good already and you don't really know how these things work, you're not going to be a lot better. But if you are really good, you really understand how the machine works, then now you've just got an upgrade in your tooling. Your tooling is now 100 times better than it was a year ago.
Got it.
So for me, that seems to be the main economic value coming. And then the question is like, what are the residual like what comes out of that? Is it that, the workforce contracts, or does it expand? I don't know, because, you have these counterintuitive things where, if people become more productive, then it might mean that we have more useful things to work on. And then, and then there's just like more good work to be done. So it might actually create more of a demand for work and for like programmers, which is what I like to think. And I think the more likely thing, I don't think you're just going to get this collapse of the workforce where now all the work is being done by like 10 people. That seems really unrealistic to me, unless we have some crazy breakthroughs. But the current trajectory with LLMs, it seems like, the best engineers will just become more productive.
Got it. Yeah. So for me, sometimes I like to think about, I call it the typewriter theory. So when admins were using typewriters, their job was to like type the, whatever reports, whatever coming in and so forth. And there was people that were hired specifically to be really good at typing. And then when the computer came along, like their jobs went away. And then like, what happened? Like, oh my gosh, the computer is going to replace the typewriter. And then what is this person going to do? They're out of a job. No, they just re-leveled, reskilled, and other people move on to things. Or things come in waves, right? And I feel like that's why every generation has something new that's going on. And for whatever reason, it just feels like as a young person, like every 2 to 3 years feels like what older people describe as like several decades of stuff that has just occurred. If you think about, I was just talking to a lady, she lives here. She's in her 90s. So she was like describing, like the earliest, airplanes and those types of things that happen, and then the car, and then like, describing events in the past that just kind of sounded really just ancient.
Yeah.
But it's now it's like, okay, the model just dropped. Last year we had something that, ChatGPT 4, GPT-4 came out, and that was just mind blowing to us. The mainstream media just is kind of still, people don't really know. Like if I go talk to other people about, have you used ChatGPT in my neighborhood? They're probably like, no, like, and so forth, even though we live in the Bay Area, right? And there's tech and stuff. And I feel like now that these, like, we're kind of like so close to the metal of where everything is going, things are moving so fast. And like you say, like augmenting is probably going to be the bigger thing in essence. And people are going to adapt, and then things morph into newer things. And then that breeds 10 more problems, right?
Yep.
Just because this person's gone. Now
it creates new opportunities. It creates new work.
Mm-hmm.
Yeah, this doomsday scenario that no one's going to have anything to do seems a bit unlikely, but could be wrong. And maybe it's just I'm looking at things on the wrong time horizon. So it might be that, on a 20-year time horizon, that's actually correct. But I think on the 5-year time horizon, that's extremely unlikely.
Yeah. And so what were some of the, like, you kind of discovered some of these papers, you were looking at, this type of problem to be solved. You're like, hey, this is kind of a silly, fun idea. Andre Kaparthi says, like, you maybe can't do it. Then you go do it. And you're like, holy crap, this is actually possible. And now
it actually makes sense. We have this, like, me and Mo, my co-founder, have this like repeating joke that just whenever we think something's a gimmick, it ends up being real. Like it ends up being something that, like, the original idea, we couldn't tell if it was a gimmick or if it was something, if it was a left curve idea or if it was a right curve idea. But
wow,
it just keeps happening that, these gimmicks turn into actual useful things. So this Mac Mini cluster, I mean, it's useful. Like you can put together your Mac Minis, connect them by Thunderbolt 4, and you have an AI training cluster.
So you also said something about edge devices. So that's something that I've been kind of seeing more in the horizon. I have some friends that I've met online, actually. I was introduced through Ronald Monarch, and he said, hey, at this Palo Alto AI Tinkerers event, these guys have this little device. It's the e-ink display, and it's running a model locally on device. And it's like a Raspberry Pi. It's like super tiny, just crunching away 100% CPU. And they was just painting on the display. I was like, oh, wow, this looks really, really cool. And, I talked to these guys, and that's basically one of the examples of like AI running really on the edge, right? And so now with EXO, I have one of these devices with me. I bought one of these founder editions, and actually it's right there on my desk. Let me grab the distiller one. Nice. Yeah. And so with this device, it has a microphone, has a camera, and I could speak to it, and it can hit your endpoint. It should be able to hit your endpoint and then return back a response and draw it onto the display, or draw images. If you have a, something that can serve, images and stuff like that, like a stable diffusion model. It has it built in, you could do it has a mini version of stable diffusion on the device. And I feel like for learning as a kid, something that's fun and interactive, this is kind of really, really cool. And we're only just scratching the surface right now on these types of things. And I feel like that's another exploration venue that people need to kind of discover and play around with. And stuff like this, what you're doing could make it even easier for to put this in a school. And then these edge devices now don't have to do that inference. They could just go talk to the endpoint locally. Don't have to worry about internet or infrastructure too much. Just kind of, hey, I'm going to do this thing.
I mean, the underlying theme here is underutilized resources. Mm. So I guess if you really dig down into what makes EXO make sense, it's that you have a lot of very capable devices that are obscenely underutilized. you have your iPhone sitting here doing nothing.
That's
you
right.
have your MacBook sitting there using 1% of the CPU, 1% of the GPU. You have your smartwatch that's mostly idle
Right.
all the time. And if you add up all the compute and memory that's sitting there on all these devices, it adds up to more than all the NVIDIA GPUs.
That's crazy. That's right.
So
Yeah.
I think when it comes to edge, that's the main insight and the main theme there, that, EXO is really about tapping into $1 trillion of underutilized resources that's sitting, in your home, sitting in your pocket, or it's on some, some embedded devices maybe that are just all around the world.
That's right. That's cool. So tell us a little bit more about EXO, and kind of where you're at in this trajectory. It's like, is this still like a startup idea?
Did any questions come up?
I think we just have Miguel again.
Miguel again?
Miguel's like the MVP of the chat right now, 2027.
Yeah, it would be great to get some questions from people, and also worth mentioning that EXO is open source, so you can just contribute freely. There's a bunch of bounties in the repo that you can just earn a bit of money by working on a few small initial issues, and if then you work on a few things, then we are also hiring. So we're looking for the most cracked engineers who are interested in solving this huge problem.
Yeah.
A good first start would be the issues in the GitHub repo. And if anyone has any questions regarding the issues or anything else, then I want to take this opportunity to just dive a bit deeper. And we've put out a lot of stuff. You obviously have the repo, but the repo is not that accessible. So I think we need more content out there that is more accessible, explaining what we're doing. And like I mentioned earlier with Carpathy, just being able to explain things in a very simple way that is easily consumable. So I don't know if anyone has any questions, even if you think it's a stupid question, just...
Yeah, it'd be totally helpful. And it could be around like training or around what they're doing, getting this stuff set up, on device, and trying to run it locally for yourself if you've either are setting up or have set it up.
Yeah, we have 411 viewers live right now. There must be one question that isn't from Miguel.
That's right. Yeah. I think I'm curious to see like if this is like, does X, do you think, I wonder if the number goes up and down. I think it probably does.
Yeah, because it's a separate view count. So like total view count. So I think
see.
this is the number of, it says live 411. So this is the number of concurrent viewers. That's a lot of concurrent people.
Yes.
So even just say hi if you're there in the chat.
Yes.
Something so we can see you.
Yeah, because I don't see anything. Let me see if I could pull up my own chat thing and see if I could kind of pull it into. Does it let me?
Are people able to chat?
Yeah.
Can someone just try sending a message?
Test on the chat. I'm on the computer, so like this is me sending a test from.
But it didn't come up in my chat.
Really? Oh, that's interesting.
It's not coming up here.
Huh.
Oh, it did just now. Okay.
Okay. Maybe there's a little bit of a delay. Huh. Yeah, because if I'm on the phone as well, I might be able to see chat.
Yeah, I don't want it to just be a monologue. I'm really keen to get questions.
Yeah.
And even if it's just a thought, some feedback, maybe something you want to see in EXO or otherwise, maybe a new model that you want to use. Like, are people interested in using vision models?
That's right.
Do people want to use, Whisper to transcribe audio? Do you have any use cases there? Any ideas, any feedback, anything we're doing bad?
Yeah, I'm just writing more tests.
While we wait for questions, I might just pop to the
Lou. Yeah.
Lou.
Yes. Cool. Definitely. Yes. So we're right now we're waiting for some more questions. We're here with the founder of EXO. If you just go down and back that way to the left. Yeah. And Alex, and we have this live stream set up really to connect with you and to connect you with Alex, because this has been a really interesting set of week where basically these are the two MacBooks that were running the large Llama language model. And so this is just your opportunity to connect with Alex and kind of, say hello, but also ask any questions. Like have you tried running Inference yourself? Have you tried to run this on any machines? Have you run into any problems? What are some of your biggest bottlenecks right now? If you are trying to run this stuff with open models. Would also love to hear from the community if there's anyone who's been not only trying to run this with their models and stuff, but what use cases are you actually using this for? Or what use cases may you see this used for, if you haven't already come up with some. Right now, just what interests me is like the fact that I can run like a security camera. And then, when somebody comes up with the vision model, be able to pop that in and just kind of run that on my machines. And these machines are always sitting here and they're always on anyways. So, why not have that ability so that we can, run these types of things. So I think that's really cool. And I've also really appreciated everyone who's been able to kind of join in with us live, to join on X. And I think it's really cool. We have 414 people on X, one person on YouTube, and a person on Twitch to be able to watch us live. So for those who aren't familiar, my name is Ray Fernando. I used to be an engineer at Apple for 12 years. So yes, I used to work there for a long time from 2010. And so then or 12 plus years actually, yes. And so what has been nice is that now I'm actually no longer working there and I'm on my own exploring AI. So it's been really cool to just be able to connect with you guys and, start these live streams and connect with other people who are doing really cool stuff in the community. So Miguel, I've seen that with the Home Assistant to locate items in certain rooms with vision models. Yes, I think I've also seen something similar where people have these apps and stuff to connect with vision models and stuff to, you can say, okay, where's this person? And so just, let's see, can you run XO on a mix of Intel Macs and Apple Silicon?
Yeah, someone asked something
similar. Oh, let me unmute you. Sorry, my bad. There you go.
Hello?
You're good. Yeah, you're good.
Someone asked something similar earlier. Just give the same answer. Yes. You just need to use a tinygrad inference engine.
Mm-hmm.
You can mix and match in theory. Just right now, tinygrad uses a slightly different model for let's say you wanted to run Llama 3.1. Mm-hmm. Then the tinygrad is using FP16, and MLX is using 4-bit quantization, Q4. So that obviously won't work. I mean, maybe some Frankenstein setup that would work. I've never tried it. But yeah, if you want to mix and match, then the thing to do would be to set the inference engine specifically to tinygrad, which you can do when you start XO. You can specify an inference engine, and you just do -- inference engine tinygrad, and that should work. Someone put it in a pull request recently to make it so that Intel Macs are detected correctly, because before it was even on an Intel Mac, it would try and run on Apple. It would try and run MLX, which isn't compatible. But yeah, that should be fixed now.
Copy that. Yes. Cool. Yeah. So this is your chance right now to ask questions for people. It's going to try to make this more of like an interactive stream. Not much of a monologue. We're just kind of warming up the audience here, and appreciate everyone who's been able to kind of tune in. We have about 400 something people. And are you building stuff with the MLX? Are you building anything in AI? Let us know. Just even drop anything.
Let us know what you guys are doing, what you are interested in AI. Is there anything that you're excited about? What do you think of Llama 3.1? What do you think of the Mistral 2?
Yeah.
Who's better, Mistral or Llama?
Yeah. Yeah. Who's actually building stuff like that? Because we want to know. And this is your stream. This is your chance to kind of hang out with us here. But yeah, so I think Whisper for secure on-site transcription would be really cool for TV shows. Secure on-site
transcription
for TV shows. Oh, because maybe they have to do when they're filming a TV show. I'm not really sure.
Yeah, what do you mean by that?
Yeah. Run the bathroom real quick.
Yep. Can you elaborate on that, please? Any comments, thoughts, feedback? just make sure I can see the chat. Yeah, Human, what do you mean by that? Whisper for secure on-site transcription would be really cool for TV shows. Miguel says he's porting the RVC, retrieval-based voice conversion project, to MLX for inference of voice models. That sounds really cool. If you're interested in what we're doing at EXO, then it would be great to have support for RVC and EXO. I don't know how big these models are. They might be quite small, so I'm not sure if it makes sense to run EXO, but yeah, how big do these models get, Miguel? Because I know Whisper is pretty small, right? Whisper you can just run on a single device. Like the app that we were running earlier, Apollo, I'm pretty sure that's running Whisper, and it just runs fully on the iPhone. It's like a gigabyte model. Even the Whisper Large is only a gigabyte.
Oh, I see. Oh, yeah, these are some of the questions that are rolling in. So it's like I am porting.
Yeah, I just
Okay.
read this one
Okay.
and just asked for clarification. Like, I'm just curious, how big are these models? Because, you know, the thing right now that EXO shines for is running these really large models, which is why Llama 3.1405B was really interesting, because that one is just gigantic, you know, 800 gigabytes. RVC models are 300 to 800 megabytes. Okay, well, in that case, then I don't think that would make so much sense for EXO. Maybe just as one thing I wanted to do is I was using Apollo for the voice, but I think it would be cool if, you know, you could just do that. Like EXO you can run it with dash voice or something, and then you can just talk to it. So you could maybe just tap a button to activate it,
Right.
and then it just transcribes what you say.
That'd be so cool.
And it could run on a single, like the transcription itself could just run on a single device. It doesn't need to run in a distributed way because the models are small enough and fast enough. But yeah, that was an idea. So maybe you could still add support, but just not in a distributed way. To be honest, if you add it to MLX, then it's easy enough. One feature request from me regarding that, Miguel, would be make it so that you can stream audio and stream audio in and stream text out, rather than giving an entire audio clip and then getting out an entire text output.
Right.
This is a huge quality of life improvement for the user, because if you just go down, like upstream from what the user wants, right? The user just wants low latency. They want to be able to talk in real time and get a response back.
Yeah.
And having streaming support is pretty much necessary, because otherwise you would need to chunk the audio, and you would then run an inference on each chunk and then get that as an output, which is probably quite slow, right? Because if you did 1 second chunks, then it's a minimum of 1 second latency.
Yeah. So for those who are just tuning in, this is basically our like question and answer section for those who are just kind of hanging out and have you, just we want to know, have you been playing around with this AI stuff? Have you been playing around with EXO Labs? What are you doing with these
It
models?
might be that people are asleep. A lot of my audience are asleep right now because it's 4 p.m. here in the Bay.
Yes.
And that means it's the middle of the night in the UK and Europe.
Yeah.
And a lot of our active community is there. Also,
Yeah.
even New York is quite late right
Yes.
now. It's Friday night
Yeah.
in New York.
Yeah.
It's probably like, what is it? Like 10 p.m. or something, 11 p.m. in New York. So
Yeah, maybe we should start to kind of wrap it up and stuff with the music and stuff. So I think this is probably a good time to kind of wrap up the show and, thank everyone for participating here, because it's just been a really cool interactive stream, really, for us to connect with you, for the audience and so forth. And it's just been a real pleasure to just have you on and just get to talk about our experience with EXO. And for me to actually just be able to live this live with you, I think it's just been amazing and crazy week to actually meet you in person, to have this discussion. And I know you're headed back to the UK probably tomorrow or something, so you're going to be gone. But next time you're back, I think it'd be kind of cool to, as more people are playing around with this, to do another like live session and also have Mo is here as well. and then maybe do some more demos and stuff, because I think people like the demos. People like that stuff.
Yeah,
so.
for sure. I'm sure by that point we'll have a lot more to show. Yeah, we're working on a lot of exciting stuff, and you can get involved as well. So if you want to contribute, the repo is open source, github.com/exo-explore/exo. You can also find it in our Twitter bio. We have a bunch of bounties available, and we have also just loads of really interesting issues that you can get involved in. And we're also hiring. So if you're interested in what we're doing, then and you're a cracked engineer, then we should talk.
Definitely. Thank you everyone very much for joining in, and we'll see you next week. Take it easy, y'all. Peace and broad.